Hello, we are José, Diego, and Paulina, and we represent Tecnológico de Monterrey, Mexico City campus, and we are part of a Cobalt CCM racing team. And we present AI-driven data analysis for energy efficiency model design for the Altair Global Student Contest in first category. So what is our challenge here? We compete in short marathon, which students compete in a global competition and design and build high-efficiency vehicles, in this case, prototypes, applying new technology, innovation, but also problem-solving skills. So what are we doing here? How can we use the least amount of energy possible and get the most efficient with every lap or attempt during this competition? So how are we going to do it? So we obtain our data from our car, then we obtain the CSV and make the data preparation, and finally find the best predictive models. It's our first time using AI, so we need to have different models in order to obtain which one is the best. So now what? So we customize the parameters and also make our own model, and finally determine which variables affects our car efficiency. So define the best strategy, but not only that, construct the best car for the next season.
First, we use the retrieve operator to obtain the database. Then we use the cross-validation operator to train and test our model, in which in this case is the decision tree based on the results of the auto model, which was the model with the least error. Here we use the decision tree operator, and in the testing part we apply the model based on the training performance, and we also put a performance operator to measure its metrics. Then we use the model simulator operator, like to predict what will the value of the current be when using like specific values of the other variables. And finally, we use the explain predictions operator to know which variable supported the most the predictions and which contradicted. And finally, we can also obtain like a global weight variable, in which we can know which variable has a bigger effect on the current. Here in the results, here is the simulator with all its functions, then the database, the predictions, and the visualizations. Here the regression tree, the performance vector with all its metrics, the weights table, and the explain predictions object.
So for the results, we obtain our first the auto model. So we decide to use the decision tree because it's the best one related with the relative error that we obtain over here, but also we had the best performance.
Based on the weights table, we know that the variables that had a bigger effect in the current were speed and altitude by far. Another result we got is this table that shows which variables and by how much support and contradict the predictions made by the model. And in this case, there were also the speed and altitude, the one that influenced the most. And finally, the correlation has a value of 0.953, which is a strong one, and can be confirmed by looking at the scatter graph of current versus prediction current.
This real data impact also has a real analysis directly to the automotive industry. So we create also electric vehicles with a lower energy consumption, and also sustainability is one of the main pillars. And we are also looking forward to implement sustainable materials and make this analysis with compare with previous prototypes.